Today on How It's Made. Solid tires. Cheesecake. Canoe paddles. And globes. Solid rubber tires are designed to conquer the toughest turf, the kind of rough terrain found at construction sites, landfills, and mining operations. These places are full of hazards that would flatten ordinary air-filled tires, but solid tires don't go flat. Even with a dozen nails sticking out of them, these big boys just keep on turning. Strong and dependable, these tires are ideal for heavy work. And because there's no inner tube, you never have to worry about getting a flat. It all starts with a wide strip of partially processed rubber. As the strip is forced through a series of holes, it's turned into a long, tubular shape. Next, hot cylinders roll it thin and soft, like a pie crust. In another part of the factory, the tire's metal frameworks are being prepped. A worker moves them along an overhead rail into a special chamber. Steel pellets are added to the mix. Inside the chamber, a machine tosses the pellets around and the friction polishes the metal tire frames. Next, workers spray on a coat of primer and apply an adhesive. Then, one by one, the frames are mounted on a mechanical arm that's positioned in front of the rubber rolling system. The arm moves the tire frame forward to meet the turning cylinders. The metal surface, still tacky from the glue, easily takes up the freshly rolled rubber. Depending on the kind of tire being made, the machine can layer the rubber around the frame up to 100 times. Then, workers weigh the tire and slice off bits of rubber until it meets specifications. This solid tire is now in good shape, so it moves on to the next stage. Over at another station, they're building a different type of solid tire. This one has no metal framework, so it can fit on a rim made for an air-filled tire. Rubber strips are wound around a metal hub that serves as a mold. Then, a heavy press squeezes out any air pockets. These rubber strips contain recycled material, which is stiffer than regular rubber. This will help the tire hold its shape in the absence of a metal framework. Now it's time for some tread. Workers begin the process by spraying a release agent onto a mold so it will be easier to remove the tire later. Then they lightly glue the ID label and serial number plate to position them for transfer to the tire. The tire is centered in the mold with a metal ring. Then the top section of the mold is lowered into place. Now it's time to get cooking. The mold is hoisted to another station and sandwiched between two steaming hot plates. The searing temperature melts the rubber into the crevices of the mold. Minutes later, the mold is open and out comes a treaded tire. The heat has also vulcanized the rubber, a molecular change that makes it much more durable. Changing one of these tires isn't a job for just anyone. Typically, a specialist travels to the work site and switches tires using a heavy-duty hydraulic system. And that's how you put a solid tire on a wheel rim made for an air-filled one. Big tires with metal frameworks go into this autoclave to be shaped and undergo vulcanization. A forklift, equipped with solid tires, of course, extracts the finished tires from the autoclave. And now they're ready to roll. When we return, another round creation. People associate cheesecake with New York, but actually, it comes from Greece. The ancient Greeks served this rich delicacy to the athletes of the first Olympic Games in 776 BC. The Roman conquest spread the dessert across Europe, and many centuries later, European immigrants brought it to North America. The ancient Romans even brought cheesecake to their temples as an offering to the gods. The basis of a cheesecake is its rich, creamy filling made from ricotta, neufchâtel, or cream cheese. But first, bakers need to make the crust, similar to a butter cookie. For a batch of about 5 dozen cakes, this bakery combines 50 pounds of butter with 10 pounds of sugar. Next, 16 egg whites. Then, 25 pounds of flour. After mixing just long enough to incorporate the flour smoothly, a conveyor belt shuttles the dough to a vat. Gravity pushes the blob of dough through a slot at the bottom, expelling a sheet less than a quarter-inch thick. A dusting of flour prevents the dough from sticking, not just to the conveyor belt, but also to the rolling and cutting tools. This prickly roller perforates the dough sheet. The holes allow any trapped air to escape during baking, which prevents the dough from shrinking and ensures a flat, bubble-free crust. The next roller has plastic circles that work like cookie cutters, slicing the dough into cake-sized discs. The leftover pieces go into new batches of dough. Each dough circle goes into a pan, then bakes at 375 for 16 minutes. Meanwhile, the batter starts taking shape. For a batch of about 20 cakes, the bakery combines 25 pounds of cream cheese with 2 pounds of cultured sour cream. That sour cream processed a little longer than usual to give it extra flavor. After slowly mixing in 15 pounds of sugar and about 2.5 cups of flour, workers blend in 3/4 of a cup of vanilla extract. Now they get cracking with 1.5 dozen eggs. That's the recipe for plain cheesecake. Flavored versions come with extra goodies. This batter is caramel pecan. It's paired with a chocolate cookie crust. As the baked crusts arrive, sprayers grease the inside of each pan with butter so that the cake will slide out easily after baking. Then a machine called a depositor shoots in just the right amount of batter. The pans now enter a tunnel-shaped oven that's almost 25 yards long. The temperature inside is a toasty 350 degrees. By the time the cakes exit the other end, they're fully baked. These 10-inch cakes take just under an hour. From the oven, the cheesecakes go onto a cooling conveyor. And by the time the hot cakes do the nearly hour-long circuit, they're at room temperature and ready to come out of their pans. From there, most cheesecakes go straight into the storage freezer, but there are a few exceptions which detour to the decoration department. This Belgian chocolate cheesecake isn't complete without a big squirt of chocolate ganache, a decadent mixture of chocolate and cream. Workers spread it all over, then make swirls with a decorating comb. And now the final touch, a sprinkling of cocoa. Some cakes go into an automated cutting machine that divides each cake into 14 equal slices and inserts parchment paper in between them. Back at the decorating department, they're putting shards of chocolate on a mud pie, a combination chocolate souffle chocolate cheesecake with pecans and coffee mousse topping. You might want to put off that diet just for one more day. Coming up, an age-old implement gets a new spin. They keep us from going adrift, and no one wants to be up the creek without one. Paddles have been around so long, no one knows who invented them or when. But there's no question they've evolved. Made with sophisticated craftsmanship, today's wooden paddles really go the nautical mile. Modern paddles are often made from a blend of hard and soft woods for a product that's strong yet lightweight. First, wooden boards are fed into a multi-bladed ripsaw that slices them into uniform strips. Each strip has a flat, smooth joint on the side. Glue is rolled onto those flat joints, and then the strips are pressed together. These glued sections will be used to make paddle blades. Over at another station, workers are creating the paddle shafts, 2 at a time. They glue shorter pieces of wood for the handles and clamp them together to allow the glue to set. The blade chunks are arranged in a much bigger clamp. Then the glue-coated ends of some shafts are wedged between the blade pieces. In a process called lamination, the blades are bonded to the shafts. The laminated paddle shapes are called blanks. Next, the blade design is traced onto one of the blanks. And the design is cut out with a bandsaw. Laminated wood doesn't warp easily. This allows the factory to produce wider blades which give the canoer more power through the water. But paddles cut from a single piece of wood have a more traditional look and feel, and some canoers prefer them. These narrower paddles are made with cherry wood. Modern tools make quick work of a design that hasn't changed very much over the centuries. In no time, a basic paddle has been carved from a single piece of wood. Next, the edges are rounded off with a large router. It shapes and contours the paddle to its final dimensions and gives it a smooth finish. In just minutes, that chunky-looking piece of wood is transformed into a sleek traditional paddle. Meanwhile, back in the laminated paddle department, notches are sawed into each paddle blade. Workers mix up a liquid plastic concoction. Then pour it into the slots to harden. The plastic gives the paddle tip some extra protection against rocks and other obstacles in the water. Now it's time to improve the profile of the laminated paddles. With the same type of router used to shape the solid paddles, workers fine-tune the design. Both types of paddles then get a heavy sanding. The final touch is to taper each paddle head so that it's much thinner at the tip. Trademark information is branded onto each paddle using a hot iron. Then it's time for the paddles to take a dip in a tank of varnish that contains a sunblock. The varnish both protects the wood and enhances its natural beauty. The paddles are suspended on an overhead conveyor to dry. And soon, they'll be on their way to a waterway near you. Up next, a factory that makes the world go round. Because the world is round, flat maps don't give us the full picture. A globe is the most accurate representation of the Earth. It depicts countries in true spatial relation to one another and better defines latitude and longitude lines. At the Globe Factory, production revolves around world events. As war and political upheaval redraw boundaries, these spherical maps have to be constantly revised. Globe construction begins with a big roll of cardboard. A machine pulls it under a roller that coats it with glue. A knife then slices the cardboard into smaller pieces, which will serve as liners for the maps. One more coat of glue, and then the liners are attached to the back of maps. Heated rollers press them together, completing the seal. Each map represents a hemisphere. A powerful press now cuts the maps into a pinwheel shape. Each map must be carefully positioned in the cutting press. After all, one false move, and a whole country could end up on the factory floor. It takes 2 punch cuts to do the job. Then the excess paper is pulled away, leaving behind a map divided into 12 spoke-like sections. Here's a top view of that cutting press. It acts like a giant fist to punch out pinwheels. And now it's time to shape the world. Workers place a map cutout and a liner into a mold. It rises into a heated cavity that presses the paper into a bowl-like shape. One hemisphere down, one more to go. The southern hemisphere is created using the same type of mold. Molds also emboss each map to represent the peaks and valleys on the Earth's surface. Here's an inside look. The raised and indented sections of the molds allow people to see and feel variations in the world's topography, both above ground and underwater. With the hemispheres complete, it's time to go global. The northern hemisphere goes for a spin while a razor blade trims the edges. Then the lower hemisphere takes its turn while a nozzle beads hot glue along the inside. This stiff cardboard ring adheres to the globe and gives it some reinforcement along the equator. Glue is applied to the northern hemisphere, and it is fitted over the ridged edge of the southern one. The two halves are precisely aligned. Then tape is attached over the seam. This both disguises the seam and marks the equator. Next, each globe is mounted on a pedestal that's attached to a metal arc called a meridian. Suction to the top of the globe, the meridian will allow the Earth to revolve. From fragments of paper and glue, a whole new world's been created in just a couple of hours. Globes tell us where we are and help us figure out where we're going. They come in many different languages, and because they help us get our bearings, you could say they make the world a better place. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.